What we're going to talk about in this section is, well, we're really getting into what's accurately, or what's called trigonometry. And when we're talking about trigonometry, well, this is, first off, we're talking about these right triangles. And so with a right triangle, we know that one of those angles has to be a 90-degree angle. And usually when we're talking about a right triangle, we're describing one of the angles, one of the other angles of the right triangle. So not the 90-degree angle, we're describing this angle, in which case, I might call this theta or something like that. Or angle A is actually how it's labeled in this one, capital A. And so everything, you can describe the entire triangle using that A as a reference angle. You can say the side that's opposite the angle, that's this side over here, that's the side BC, that's this angle. Or you can say the leg that is adjacent to angle A, that's this one right here. Or you can say the hypotenuse, that's that one right there. Or you can say the other angle up here. So you can describe anything in the triangle using this angle as your reference. Similarly, you could use everything in the right triangle using this other angle as the reference. You could say the side that's opposite angle B, which is this one down here, the leg that's adjacent to angle B, which is this one here, or again the hypotenuse. That's not really using B as a reference angle at all, it's just the hypotenuse. In a right triangle, there is a fixed relationship connecting the sides of either of those acute angles. So when you say the acute angles, we're talking about either of the angles that are not the 90-degree angle. So connecting the sides of those to various ratios. So if this angle right here, we're saying that that's a 20-degree angle here, then the ratio of these two sides, A1 to C1, is the same regardless of how big this triangle is. If it's a little bit bigger, as long as it's still a 20-degree angle there, then A2 over C2, A3 over C3, A4 over C4, all of those are the same ratio. It's the same value. As long as I take this number divided by that number, it's going to give me the same ratio. So in general, we call this, this would be A over C, or we could call it A over C. But we actually have a specialized name when we're talking about the side, the leg that's opposite our angle divided by the hypotenuse. We call this sine. So now when you see this spelled out, it looks like sin, S-I-N, but it rhymes with dine, not with din, or not with in, whatever. So we pronounce this sine. Sine of A, sine of angle A would be the side opposite angle A divided by the hypotenuse. So in this particular drawing, sine of A would be A over C. Sine of B is taking the side that's opposite B, that's this angle, this side right here, and dividing it by the hypotenuse. So B divided by C, little lowercase b divided by lowercase c. You can see that's written right there.